Alright guys, so this is Unit 5, Day 3, Part 2 of the video, and we're just going to jump into some problems here. So we're going to solve by substitution. So the first part says, I will isolate, and you get to pick the x or the y. So those are your options always, and then it's either your first or your second equation. So like I said in the previous one, we want to isolate the one that's going to be the easiest. So in this one, I'm going to say this first equation is already isolated, so I'm kind of happy about that. So we're going to isolate the y because it's already done, and in the first equation because it's already done, like I said. So now, wherever we see this y in the second one, we're going to plug in 3x minus 13 into the equation. So we have a 3, an x up plus 4, plug in the new y, equals negative 7. Now let's solve for x. So 3x plus 12x, not quite sure. What is 4 times negative 13? Negative 52 equals negative 7. Let's combine some like terms here. 15x minus 52 equals negative 7. Inverse operation, so we're going to add 52 to both sides. We're going to get 15x is equal to, not quite sure, negative 7 plus 52 is a 45. And then we're going to divide both sides by 15 to get x is equal to, let's do 45 divided by 15, which is a 3. So we got half of our answer so far, right? I know it's a 3, and now I have to find the y. So I'm going to take the first equation, y equals 3x minus 13, plug in my x now that I know to be 3, and now we're just going to solve. So y equals 9 minus 13, y equals, let's plug in our calculator, 9 minus 13, negative 4. So 3, negative 4 is our solution. Alright, let's jump into example E. So I want to isolate, and again, I'm going to look at the coefficients, and I realize the y is probably going to be the easiest because it technically only has that 1 in front, it's like a negative 1. So let's isolate the y in the second equation though. Okay, so 3x minus y equals 11. I'm going to subtract 3x on both sides. Negative y equals negative 3x plus 11. And then I'm going to divide everything by a negative 1 to get that y by itself. I'm going to double check. Negative 3 divided by negative 1 is a positive 3x. Positive 11 divided by 1 is a negative 11. Okay, so we have this isolated one, and now in the other equation, wherever I saw a y, I'm going to replace it with this 3x minus 11. So now we have a 2x minus 4y equals 14. Plugging it in, 2x minus 4 times 3x minus 11 equals 14. So we have just substituted, right? Instead of this y, we have all of that inside. 2x minus, let's distribute. So 12x, negative 4 times the negative 11, positive 44. Let's combine our x's. So we have 2 minus 12 to get a negative 10x plus 44 equals 14. Let's get x by itself. So we're going to subtract 44 on both sides. Negative 10x is equal to 14 minus 44, negative 30. Divide both sides by a negative 10. X is equal to negative 30 divided by negative 10 is a positive 3. And I'm going to set up my answer by writing it already in the coordinate notation, right? So I don't forget. So we have our first answer, or half of it I should say, and now we need to figure out the y value. So I'm going to take that first equation, which we had a y equals 3x minus 11. Now I'm going to plug in the 3 inside of the x spot, and we have 9 minus 11, and we get a negative 2. So I'm going to go back into my coordinates, right, and put in that negative 2 into its spot. Nice job. All right, now let's try this last one. I'm going to make this a little bit smaller so we have a little bit extra room here. All right. So I want to isolate, ooh, this looks weird. Well, it looks like both equations have the y isolated, so the y, and it doesn't matter because they're both already isolated. So I'll just say the first equation. So if the first equation is already isolated, that means I'm going to take all of this and I'm going to plug it into the y spot of the other equation. So negative 4x plus 8 got plugged in, and then I copy everything else the same. Now let's just solve. So we have to, I'm going to add 4x. I like to move my x's, the smaller one always, so I don't deal with negatives. We get a 5x minus 7 plus 7 plus 7. I'm going to go 8 plus 7, double check, that's 15. Great. Divide both sides by 5. X is equal to 3 I'll get. I'll start my coordinate. Alright, so now we have to figure out what is y. So I'm going to take that first equation that was isolated, y equals negative 4x plus 8. I'm going to plug in a 3 for the x. I'm going to solve. So y equals negative 12 plus 8. Y equals negative 12 plus 8, negative 4. I'm going to go back to my coordinate and write a negative 4 in its spot. Alrighty, so we did 3 of these problems and we got our nice 3 answers, and we notice that we're writing them in a coordinate, right? So x comma y, don't forget that. Alrighty, and let's try at least one of these guys from example 2. So we're going to set up a system of equations to solve for the missing sides of the rectangle. So the perimeter of a rectangle is 44. The length is 1 more than twice the width. So first thing is we always want to draw out a diagram. So we're talking about a rectangle, and I know this is the length and this is the width. Okay, so let's break this apart. The perimeter is 44. So I know I'm going to say P is equal to 44. And I know to find the perimeter of a rectangle, I have to add up all the sides. But now I have to annotate and figure out what does this part mean in math, right? So we're going to read it. Length is, so that means length is equals 1 more than twice the width. 1 more than means addition, twice the width. Twice the width. Twice means to multiply. Great. So I have that, but did I say anything about the width? The width is 5, the width is nothing, right? So now, just like the previous ones, I'm going to take this 1 plus 2w and I'm going to plug it in for the L side. So I'm going to go in and do 1 plus 2w, and I'm going to double check that I label all my sides because I don't want to mess up when I have to add them, okay? So 1 plus 2w. Perfect. Okay, so let's make up our equation. I have how many with sides? So I have 2 of the green, so 2 times the green sides plus, and then I also have 2 of the blue. So I can represent it by 2 times the blue, and that should equal my perimeter, which is 44. So let's just clean this up. 2 times W, 2W, 2 times 1, 2, 2 times 2W, 4W equals 44. Clean it up a little bit more like the previous problems. Let's combine some like terms. So we get 6W plus 2 equals 44. I'm going to write up here now. So we had 6W plus 2 equals 44. Inverse operation, subtract 2. 6W equals 42. Divide both sides by 6. W equals, I'm going to do 42 divided by 6 is 7. All right, but that's only part of our answer. That's our width. And remember, you already made an equation up for length. So length was equal to 1 plus 2W. Now just plug in what we have for W. So length equals 1 plus 2 times 7. Length equals 2 times 7 is 14 plus 1, 15. Okay? And then I'm going to attach my units. So we have what here? Centimeters? And then we have our 2 answers, okay? So on the bottom it says, I prefer to use the substitution method. And when do I want to use that? I want to do this when one of the variables, so that means the x or the y, is already isolated. That's the easiest time to use this one, okay? Put a star next to this, highlight it, but you need to understand out of the 3 methods that you're going to be taught, which one is the best one to use, okay? So for substitution, it is the easiest to use it when one of your equations is already isolated. So that is like example 1a, right? That first equation, that y was already isolated. All right, guys, that is the end of day 3. Keep up the great work. Keep advocating for yourself, okay?